Good afternoon, class. We are looking at practice test number 3, module 3, covering chapters 5.4 and 8, section 5.4, right triangle trigonometry, chapter 8, application of trigonometry, 8.1, the law of sines, 8.2, the law of cosines, 8.3, polar equations. All right, so given the right triangle, as you can see, we want to find CD. And so there are several ways of approaching this. One easy way is, look at this one. Obviously, this is supposed to be 180. Therefore, subtract 36 from it, and you get 144 degrees. So one more time. This is 180 degrees. The sum of these two must be 180. So 180 minus 36 gives us 144. Now, if this is 18, this is 144. We add them up, subtract it from 180, and we get this one, which is also 18 degrees. Again, in this case, 180 minus the sum of these two, 144 plus 18. Excuse me. All right, so if this is 18 degrees and this is 18 degrees, this side and this side must be identical. That means both must be 200 because they are, this one is an isosceles triangle, right? So this must be 200. We are dealing with the isosceles triangle. If we have two angles that are equal, then the two sides must be equal. We want to find this distance. Sine of 36 degrees is the opposite, which is CD, over the hypotenuse, which is BD, and we do have this one to be 200, and therefore CD is the product of 200 and sine of 36 degrees. And at this point, of course, you have to put it into a calculator to come up with the answer. And we get an approximation here, as you can see it. And we are done. 117.557 feet. As far as the number of decimals, as always, you want to pay attention to the way they ask you, okay? And you follow that. Solve the right triangle. So this is 90 degrees. A is 8, B is 2, C is 90 degrees. So reminding everybody, Pythagorean theorem, A squared plus B squared equals C squared. Sine is the opposite, in this case, sine of A, the opposite A over the hypotenuse C, and sine of course, B would be B over C. Cosine is the adjacent over C, tangent is the opposite over the adjacent. It's very straightforward. These are some of the information we are supposed to have from before, and we do, and now all we have to do, just start with what is given. 8 is given, 2 is given, so A squared plus B squared equals C squared. So let's throw in the information that we have. A is 8, B is 2, capital A, capital B, capital C, those are the vertices. So this is the side B, this is the side A, this is the side C, and C squared is 8 squared plus 2 squared. $68. And so C is the square root of 68. Now, square root of 68 is the square root of 4 times 17. 4 comes out. This is an exact answer, everybody. And then approximation, 8.24. So we have all sides And obviously, this is 90 degrees. All we have to calculate either A or B. For example, tan of B is the opposite B over the adjacent A. And the reason I'm going to go with that, because I want to use the given rather than what I've just calculated. Always use the given, because in case we made a mistake here, this is the given. So B over A, or 2 over 8, or 1/4. This is 1/4. So B is tan inverse of 1/4. You put it into a calculator. 0.25 radians, about 14.03 degrees. And of course, if we have a B, it must be 90 minus that, 75.97 degrees. And we're going to summarize everything that was given and everything that we found. Okay. So everything is pretty straightforward. A girl standing 20 feet in front of a Disneyland Christmas tree. They start at the top of the tree to the bottom of her shoes, makes a 60-degree angle. How tall is the tree? What is the distance between the girl and the star? See, draw a diagram. Even if they don't ask you, you have to, because you have to justify your work. So here's the tree. Here's the star. The distance between the girl and the tree is 20 feet. This angle is 60 degrees. How tall is the tree? We don't know X. And what is the distance between the girl and the star? C, we don't know. We are looking for those two values. All right, so notice what's given and what's missing. Tan of 60 is the opposite X over the adjacent 20. And therefore, X is the product of these two, 20 tan of 60. Tan of 60 is a common arc, square root of 3. So precisely square root of 3, or roughly 34.64 feet. We should always go with the exact answer. You want to put it down. And so then you do the approximation. This is extremely important, everybody. All right, so we got that. And now the next one is to find the missing C, which is A squared plus B squared. So now that we have this side and we have this side, there are several ways of handling it, okay? You can say, for example, cosine of 60 is 20 over C, and put it into a calculator, okay? Or you can say A squared plus B squared equals C squared. Therefore, C squared is 20 squared plus X squared, which is 34.64 quantity squared. You put it into a calculator, you get almost 1600, and the square root results in 40 feet. Okay, class? Again, very straightforward. So here's the triangle, and we want to find AC, angle A, angle B. Those are missing in action. So side angle, because we have 8 and 5, and it's not an included angle. So we use the sine law, which says sine A over A, sine B over B, sine C over C are equal. So sine A over A sine B over B. Since we have 67 degrees, then we have to use sine C over C. This one we have. This one we have, everybody. So let's just start with what we have. Sine C, that means sine of 67 over the opposite side 8. And then whatever is missing, sine A is missing over 5. That's one way to do that. And of course, cross product means sine A is the product of these two divided by 8. Putting it into a calculator, you get 0.5753. Therefore, A is sine inverse of this number. You put that into a calculator, results in 35.1 degrees. And remember, sine is positive in the first and second quadrant, so this acts as a reference arc. If you subtract it from 180, you get 144.9. I want to make sure that we understand that this acts as a reference arc. So in case 2 is 180 minus 35.1. So two possibilities. Either it's 35.1 degrees or 144.9 degrees. However, when you look at the number is way too large, it's not possible. Why is it too large? Well, A, B, and C, they must add up to 180. If you look at this one, 67 and 144.9, this is going to go beyond 180. That's why we don't have the second one. We just want to continue with the case one only. So we have 67 degrees. We have 35.1 degrees. So the last one, angle B, would be 180 minus sum of the two. So A and C, if you add these two, you get 102.1 degrees subtracted from 180, and you get 77.9 degrees, which means now we have all the angles. Now we continue with the next part. Sine of 67 over 8, we keep that. Okay. Sine of B over B. So B is 77.9. Sine of 77.9 over AC, the cross product means if we multiply this to divide by this, we get AC. You have to put it into a calculator, and however many decimals that they want, using a calculator results in 8.5, and we summarize what we just found, this one and this one and this one. Okay, so our findings, we summarize them, everybody. So solving side-side angle, the reason it's ambiguous, we just looked at an example. We have to look at the second possibility for the angle, and it either works out or it doesn't. Okay, so just actually, if we go back to this one, we notice it didn't work here. If it works, we have two possibilities. Okay, if this number is larger than 1, or it's less than -1, then there is no sign. Ultimately, this number will tell you whether it works or not. Okay, so H is B sine A. If A is less than H equals B sine A, there is no triangle. And in this case, when H is equal to B sine A, and we have it in this format, we end up with two triangles. Would have this one or the entire triangle. And so, having said that, let's look at this case where we have A and B, two sides and one angle. Draw a diagram. Now, when you draw a diagram, even if it's not to scale, it's okay, class. Just have a rough idea, okay? So A is 50 degrees. Opposite that is lowercase a, and that is given as 3. Capital B opposite that is 2, and capital C opposite that is lowercase c. Okay, so those are the ones that we are going to find. And so having said that, let's start with what we can. Using the sine law and the fact that the interior angles, they must add up to 180. So we get sine A over A, that means sine of 50 over 3, is sine B over B, that means sine B over 2, sine C over C, and everything is missing about that. Now, first, we are going to solve this. Okay, everybody, which means the cross product results in sine B being 2 sine 50 divided by 3. Sine B is 0.511. So case 1, B is sine inverse of that, 30.7 degrees. So that's the first case, everybody. Case 2, remember, this works as a reference arc. Sine is positive in the first and second quadrant. So 180 minus that. 180, again, I want to make sure everybody understands that we have 180 minus 30.7 degrees, okay? And case 2 is 180, as I mentioned, minus 30.7, which gives you 149.3. Does that work? Well, let's find out. This one and this one, add them up. More than 180, it's out. So the second case fails. So it's important to understand how we get to the second case, everybody. Okay, and why it fails. Okay, so just work with the first case, and that's all there is to it. So the first case, meaning we have 50 and 30.7, add them up. So that's not possible. So we're going to add those two. We get 50 and 30, 80.7. Subtracted from 180. 99.3 is the last angle. So right here now, we have sine of 99.3. And so cross product tells us C is the product of these two divided by sine of 50. 3.86, and we summarize our findings. Draw and solve triangle A is 8, B is 3, C is 6, and again, we have the sine law, cosine, and so forth. Obviously, we have 1, 2, 3 sides, so we have to go with the cosine law. And to go with the cosine law, because we have all sides, let's go with cosine of A, which is B squared plus C squared minus A squared over 2BC. Okay, so we are going to do the drawing in the following manner. So A is 8, B is 3, C is 6, and sometimes it may not be to scale class, okay? In fact, I'm not too sure if this is in scale to scale at all. But using this formula, B squared, this is 9, C squared, 36, minus 64, 2 times 3 times 6. So just plug it. 9 and 36, 45 minus 64 is negative 19. 2 times 3 times 6 is 36. So negative 19 over 36, which makes A cosine inverse of this number. Negative 19 over 36. Putting it into a calculator will result in 121.8 degrees, everybody. We have to find one more angle. We have a choice at this point. We can go with the sine law, by the way, because we have all sides and one angle. We can go with the sine law. I want you to know that. But if we continue with these thoughts that we used cosine A, now we can use, let's say, cosine B. And it's important to understand, if cosine is B squared plus C squared minus A squared over 2BC, then cosine B, so replace the A and B and interchange A and B. So if this is B, cosine B, then this should be A squared plus C squared minus B squared, and 2BC becomes 2AC. I hope you can see that. So A squared, 64, C squared, 36, minus B squared is 9, 2AC, 2 times 8 times 6, 64 and 36, 100 minus 9 is 91, and 2 times 6 times 8 is 96. Which makes B cosine inverse of 91 over 96. Putting it into a calculator will result in the answer of 18.57 degrees. And now that we have the second angle, the sum should be 180. In other words, this one and this one, and the missing one must be 180. So angle C is 180 minus A plus B, and A plus B is the sum of these two, 140.43, and C becomes 39.57. So we have the synopsis of everything here. Find the area. We can use area of a triangle from sides using Heron's formula as it was mentioned before. The area is square root of s times s minus a times s minus b times s minus c, where s is the perimeter, meaning add all the sides, divide by 2. So in this case, a plus b plus c, that means 3 and 6 and 8, add them up, divide by 2. And we get 8.5. So add up all the sides, divide by 2. Put it into this equation. So that means 8.5, 8.5 minus 8, 8.5 minus 3, 8.5 minus 6, and simplify, put it into a calculator. You get 58.4375. Now, if you take a root of that number, 7.644. Again, as far as the number of decimals, class, you have to pay attention to what they ask you to do, okay? Whatever they ask you. What about this case? B is 45 degrees, C is 95 degrees, lowercase c is 5. We want to draw a diagram and then solve it. We are looking at side and two angles. So obviously, we come up with the third angle first, right? Well, let's do the drawing, and it may not be to scale again. This side is 5. So this is capital A, lowercase a. This is capital B, lowercase b. This angle is 95 degrees. And this angle is 45 degrees. So those are the given. So we add these two, subtract it from 180. This is the fastest one to come up with, 180 minus b plus c. This is 140, subtract from 180, you get 40 degrees. So we get the last one as 40 degrees. And now we can use sine law, for example, sine a over a, sine b over b, sine c over c, they are all identical. So these two are given, so we're going to use them. Sine of 95 over 5. This one is given. Is sine of 45 over the missing b. And the product of these two is the same as the product of these two, which makes b the product of these two divided by sine of 95. Putting it into a calculator will give us the value of b at 355. We use the sine graph for the last one, sine of 95 over 5 we use. This time we're going to use sine of 40, the last one, sine of 40 over 8. And again, cross product. The product of these two divided by sine 95 must be a. Putting it into a calculator results in a being 3.23. And as I mentioned, as far as the number of decimals, we always pay attention to the way they want it. And this is the summary of what we have been given and what we just found. Okay, we continue with a similar question. Again, we have two angles. So we're going to use the side angle, the third angle, and the sine law. And so these are the sides. And so this is 55 degrees. This is 4. This is 20 degrees. This is C. This is B. And we are going to calculate the third angle by adding these two, subtracting it from 180. So 55 and 20, 75, and subtracted from 180 is 105. So we have all the angles, everybody. So we use the sine law, and we have these two. So sine of 55 over 4 equals sine of any of them. It doesn't matter. Start with this one or this one, sine of 105 over B or sine of 20 over C, right? And so the product of these two and the product of these two are the same, which makes B the product of these two divided by sine of 55. And if you put it into a calculator, you end up with 4.717. Also, this is equal to sine of 20 degrees over C, cross product again. C would be the product of 4 and sine 20 over sine of 55. To a calculator, it goes, and it gives us roughly 1.670. And we put all of them as a summary together. So solving a triangle shouldn't be a big deal using various laws, sine law, cosine law, and so forth. We want to use the law of cosines, or the cosine law, to prove cosine A over A, cosine B over B, cosine C over C is A squared plus B squared plus C squared over 2ABC. And I've written for you what we already know. For example, A squared is B squared plus C squared minus 2BC cosine A. Cosine is B squared plus C squared minus A squared over 2BC. So we should know what's cosine B and so forth. Now, we start with one side. It doesn't matter which side. In this case, the left-hand side seems to be more appropriate and more involved. So if I take a common denominator, obviously the common denominator is ABC, everybody. So if the common denominator is ABC, this one is cosine A times BC, so BC cosine A. This one is times this two, AC cosine B. This one times this two, AB cosine C. Now, in essence, we want to prove the top is equal to A squared plus B squared plus C squared. And to do so, we are going to look at this one and say, let's multiply this one by BC. So if I multiply this one by BC, this becomes BC cosine A, and this becomes just 2. Okay. Now let's go to this one. If this one was multiplied by BC, this must be multiplied by AC. If I multiply this one by AC, AC goes here, and the denominator is 2. This one I'm going to multiply by AB. AB goes here, and the denominator becomes 2. This one and this one. I hope you can see that. So why am I doing that? Because now I want to replace this one with this one with this one, and this one with this one. So let's do that. When we replace them, I'm going to factor the 1/2 out. Each one on the right side has a factor of 1 over 2, everybody. 1 over 2. So I'm going to take the 1/2 out. 1/2 times this plus this plus this. So these two cancel each other. These two cancel each other. What are we left with? Inside the brackets, a squared plus b squared plus c squared, and there's a 1/2 in front. This 1/2 makes any complex fraction. You can put the 2 at the bottom. I hope you're comfortable with the fraction. So again, what is inside the brackets? A squared plus b squared plus c squared. This 1/2, you can put the 2 down here, becomes 2abc, and that is the proof it is equal to the right-hand side, everybody. Let's look at some applications. An aircraft is spotted by two observers who are 1,000 feet apart, P and Q. As the airplane passes over the line joining them, each observer takes a siding of angle of elevation. Remember, this is a horizontal line or plane. If you look up, angle of elevation, down, angle of depression. So up, the angle of elevation is indicated as in the figure 40 and 35 degrees. By the way, they have explained everything. They have given us a figure. Sometimes they have more explanation, but they don't give us the figure. They don't give us the drawing. We have to come up with it. Okay. And I can't emphasize this enough that we be able to do that. So what they are asking now to the plane, as indicated in the figure, how high is the plane? So we want this H. So this is H. This is Y. I'm making up just variables. You have to define your variables. So the angle PRQ is 105. Why is that? Let's see. If this is 90 degrees, everybody, 40 plus this is 50 degrees, 35 plus 55 degrees, and the sum of these two is 105. So I hope everybody is clear as to how we arrive at the answer. If this is 105 and we use the sine law, we can say sine of 105 over 1000 because this side is given. We have to go with the sine law. And it's sine of 35 because we can find y and then h. Sine of 35 over y. Cross product. Means y is the product of these two divided by sine of 105. You put that into a calculator and it results in y, or the distance of a PR, to be 593.81, let's say about 594 feet. So why did we find y? Because now sine of 40 is h over y. And since y is known, this times sine of 40, that you get it from the calculator, gives us the answer of 381.69, almost 382 feet. Again, it's important to be able to come up with this if it's not given. For example, here again, they have given us, but this has enough information. We should be able to come up with these two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks a distance of 50 feet from house P to point R. So from one of the house, we go away by 50 feet. And that point, we call it R. Then uses a transit to measure this angle PRQ, then measures this angle, which is 80 degrees, and then walks to the house Q, a distance of 60 feet. How far apart are the houses? Now, let's say this wasn't given, just for the sake of argument, everybody. You should have started with something like this. Okay, point A, point B, point P, point Q, whatever. That's the distance that is of interest to us. So we are going to go a distance of 50 feet, and we call it something, let's say R. We measure this angle, which is 80 degrees, and then we walk towards the house, which is 60 feet. This you should be able to come up with if this wasn't given. And that's the idea. I did it step by step so you understand what happens here. And so because two sides and the included angle, side angle side is given, and we want this distance, we can use the cosine law, which obviously says a squared equals b squared plus c squared minus 2bc cosine a. So this distance, PQ squared, is 50 squared plus 60 squared minus 2 times 50 times 60 times cosine of 80. And you put that into a calculator, you get PQ squared is 5058.11. You put it, you take a root, and PQ becomes 71.12 feet roughly. So pretty straightforward, everybody. Here's an example that we have to put them together. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet and the second one 350 feet. How far are these boats apart? Draw a diagram. So one is going this way, one is going that way. They are making an angle of 135 degrees. This is going to go 300 feet. This is going to go 350 feet. The distance is of interest to us. So again, side angle side, we use the cosine law. A squared equals b squared plus c squared minus 2bc cosine a. And we want this. So a squared or bc squared is 300 squared plus 350 squared minus 2 times the product of these two and cosine of 135 degrees. Just plug in this one, 90,000, 122,500 minus 210,000. Now, this is the same as cosine of 45 degrees. In the second quadrant, cosine is negative, so minus square root of 2/2. We have all those numbers. So you find a squared, you take a root, and it becomes 600.83, about 601 roughly, 601 feet roughly. So the point is you could figure it out. Two cars leave an intersection together, traveling on courses with the angle of 45 degrees in between. If each travels 500 feet, how far apart are they? So one goes this way, one goes that way, making a 45-degree angle. Each one is 500 feet. We are interested in this distance, which is missing in action. So obviously, cosine law. So because I call this A and B, I'm going to say C squared is A squared plus B squared minus 2AB cosine theta, or cosine C. I'm showing you various formulas that you come across. So 500 squared plus 500 squared minus 2 times 500 cosine of 45. And at this point, I'm going to leave it for you to put it into a calculator and take a root, and it becomes 382.68 feet. You can do that. A similar situation, two cars leave an intersection together, traveling at courses with an angle of 30 degrees. So instead of 45, it's 30 degrees. If one travels 1,000 feet and the other one 720, how far apart are they? So one is going this way, one is going that way, and they make a 30-degree angle. One covers 720 feet, one covers 1,000 feet. And so what is the distance between them at this point? Again, we are going to go with the cosine law. C squared is a squared plus b squared minus 2ab cosine theta. So we say we start with one of them, 1,000 squared plus 720 squared minus 2 times the product of the two and cosine of 30 degrees. And again, you can put it into account. Both of these angles are common arcs. This is square root of 2 over 2. This is square root of 3. But in any event, put it into a calculator and C becomes 520.89, almost 521 feet. George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house, draw a diagram. Notice, again, reminding you, this is the horizontal side or horizontal line or horizontal plane. You look up, it's an angle of elevation, down angle of depression. So is looking up at an angle of 60 degrees. And the distance here is 35 feet. We are looking for the height. So tan of 60 is h over 35. So h is the product of these two, 35 tan of 60. Of course, tan of 60 is square root of 3, but that's an exact answer. We put it into a calculator, 60.62 feet. So it's pretty straightforward, everybody. I hope everybody can see that it's really very straightforward, not a big deal, everybody can handle it. All right, we are going to move on, everybody. All right, now George is standing 27 feet in front of a house on a hill and notices the angle of depression from eye level. The top of the house to the bottom is 73 degrees. Find the height of the house, draw a diagram, and so forth. And so this is the angle of depression. Again, similar to the previous one. And now, of course, in this manner. So let's do the drawing. So we are looking down this way. This angle is 73 degrees. This is the height missing, and this is 27 feet, everybody. 27 feet. So tan of 73 is the opposite h over the adjacent 27. So h is the product of these two numbers. You're putting it into a calculator with a bunch of decimals. 88.31 feet, everybody. All right, to move on, I want to remind you that if you have two lines that are parallel and a line that cuts it, two parallel lines, AB and CD, intersected by a transversal line, GH. The figure shows two parallel lines, AB and CD, intersected by the transversal line, GH. Corresponding angles are equal if the transversal intersects at least two parallel lines. So there's many angles here. So we call them 1, 2, 3, 4, 5, 6, 7, 8. So we can go back and forth. Corresponding interior angles found at the inner side of the intersection between parallel lines and the transversal. Corresponding exterior angles found at the outer side of the intersection between the parallel lines and the transversal. So the pairs of corresponding angles in the given figure having the same color are 1 and 5, 3 and 7, 4 and 8, 2 and 6. In the figure, AB is parallel to CD. AB is, this is the notation. Double line, AB is parallel to CD. Thus, angle 1 and 5, the blue ones are the same. 3 and 7, the yellow ones are the same. 4 and 8 are the same. 2 and 6 are the same. Alternate interior angles are equal. That means 4 and 6 are the same. 3 and 5 are the same. 4 and 6, 3 and 5. Same side interior angles are supplementary. 4 and 5, they add up to 180. 3 and 6, they add up to 180. Alternate exterior angles are equal. 2 and 8 are equal. 2 and 8 are equal. 1 and 7 are equal. Same side exterior angles are supplementary. That means you're on the same side, okay? 1 and 8 exterior, right? Outside are they add up to 180, and 2 and 7 outside, they add up to 180. So just wanted to remind you of that. Hopefully everybody is comfortable with the concept so we can move on. A balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram. So we have to really see how it looks like. Without drawing the setting, we can not see what's happening. So here's the balloon, 600 feet high. Here's the airport, 5 miles away. This angle is the angle of depression, which is the same as this angle. So we want to find this, but all we have to do, find this one, because those two are equal since these two lines are parallel. So they are alternate interior angles as far as terminology is concerned. So tan of theta is the opposite 600 feet over the adjacent 5 miles, okay? And because this is in feet, this is in miles, you have to change the units. It's easier to say 1 mile is 5,280 feet and replace it. Put it into a calculator. You get 0.0227272, and theta is tan inverse of that. Putting it into a calculator, tan inverse of this number gives us this, which is 1.3 0, let's say 1 next to it is 9, changes to 2, 1.302 degrees. A rocket takes off at a bearing of north, 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? So what do we do here? Okay, first of all, reminding you about the bearing. Everybody knows that. So north to south, okay, the closest angle to north or the closest angle to south. For example, this one would be, the closest angle would be 30, and because on the right side we say north, 30 degrees east. But this one is on the left side and the angle is 70, we say north, 70 degrees west. So that is first and foremost understanding the concept. So we have all of them. This one is missing. I hope you see that we're going to go with south 20 degrees, to the right is east, south 20 degrees east, just to remind you of what we have done. And so in this question, the very first thing we want to do, we want to look at this concept north 30 degrees east. So we are looking at this direction, this direction. So we're going to go in this direction for 900 meters. Then what happens? Then the pilot turns 90 degrees. So 90 degrees. So we make a 90-degree angle this way or that way and heads northwest. So when you, this is a 90 degree. Okay, so when you drop a perpendicular 90 degrees here, 90 degrees here. Which way do you go? Whatever they say. Northwest is going that way, everybody. And how far do we go? 1,000 meters. What is the new bearing? Let's connect them. What is this angle? Whatever, alpha. So what is this bearing? North, alpha, west. So all we have to do, find alpha. This entire angle, we call it theta. And we said this is north 30 degrees east. So this angle is 30 degrees. So alpha must be theta minus 30 degrees. So all we have to do, calculate theta. So I hope everybody's clear how we are doing it. One more time quickly. So we are going in this direction, and then this direction, 900 and 1,000. And we want north, alpha, west. Alpha is the difference between theta and 30, and theta in this triangle is tan of theta is the opposite 1,000 over 900. That means tan inverse of this number, and I can drop a couple of zeros, 2 of them. So theta is tan inverse of 10 over 9. Putting it into a calculator gives me the answer, and I'm going to subtract 30 degrees from it. So 48.01. Subtract 30, and we get 18.01. So the answer is north, alpha, west. North, 18.01 degrees west. An aircraft leaves an airport from a runway with a bearing of north 40 degrees east. Again, same direction. After flying for half a mile, the pilot turns 90 degrees and heads towards southeast, then this way then. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram. So first and foremost, let's start from the beginning. North 40 degrees, east is taking us this way. So north, this is 40 degrees east, and this distance is half a mile. Then we make a 90-degree angle. Here's the 90 degrees. We either go that way or this way. Which way do we go? Southeast. So we go this way. So that's a 90 degree. And for how far? 1 mile. And now we want to find the bearing. So let's connect the two. There is some angle here, which we can find. There is some angle here, and this is going south. This angle, let's say alpha, east. If we call this alpha, south, alpha, east. So all you have to do, notice this entire angle is 180. So 40 degrees plus the green one, which we can find from the triangle, plus the red one alpha, they must be 180. That means if we call this theta, 40 plus theta plus alpha is 180. We can find theta and therefore alpha. So tan of theta is the opposite 1 over the adjacent 1/2. That means 2. So theta is tan inverse of 2. Putting it into a calculator results in 63.43 degrees. If the sum is 180, then alpha is 180 minus the sum of 40 and theta, which is 63.43, resulting in 76.57. So south, alpha is 76.57 degrees east is the final answer. So pretty straightforward, everybody. Plot the points in polar coordinates. A is -2, 0, 1, comma, power 2. And remember, we have the rectangular coordinate system and a polar coordinate system with r, comma, theta. So polar r, comma, theta. So this distance is x, this distance is y, this is r, which is x squared plus y squared equals r squared. And P has coordinates x, comma, y, or r, comma, theta. This is the pole or the origin. This is the polar axis or the positive side of the x-axis. So 0 degrees takes us this way. If it's +2, you go 1, 2 tick marks on the right. But because it's -2, you go 2 tick marks in the opposite side, -2, 0. 1, comma, power 2. So that's the answer for this one. This is the polar axis. This is the power 2, everybody. And therefore, 1 tick mark right here, 1 tick mark, go up by 1 tick mark, and you find it. All right, we want to find other polar coordinates for 1, comma, power 2. And I'm going to remind you that in the case of a polar coordinates, we have infinitely many ways to answer them. R, comma, theta is the same as r, comma, theta at 2k pi, k is an integer. Or if you want to negate that, you add odd multiples of pi. That means theta plus 2k pi, add another pi. So in this case, because r is positive, okay, and we want this one to be negative, just subtract 2 pi. So power 2 minus 2 pi, which gives you -3 pi over 2. Now you want r to be negative, and you still remain in the first 0 to 2 pi. That means a complete revolution. So We want to stick with that. So all we have to do, add a pi and negate this 1, make it -1, pi over 2 comma pi. And the sum of those is 3 pi over 2. If you want it to be between 2 pi and 4 pi, the second revolution, and r positive, you keep the r, you go back to this one and say, I'm going to add 2 pi. So if you add 2 pi, 2 pi over 2, you get 5 pi over 2. So you get 1 comma 5 pi over 2. Plot the points first, then find their coordinates. Find the Cartesian or rectangular coordinate for 6 comma 150. Okay. So this is 150 degrees, puts us in the second quadrant, and we're going to go 1, 2, 3, 4, 5, 6 tick marks, okay? Or 6 circles, if you will, because each circle represents 1. And so, reminding everybody of polar having coordinates r comma theta, rectangular having coordinates x comma y, x is r cosine theta, y is r sine theta. So if x is r cosine theta, that means 6 cosine of 150. Cosine of 150, remember, 30 degrees is the reference arc, so it's the same as cosine of 30. However, in the second quadrant is negative. Square root of 3 over 2 for cosine of 30. For this one is negative. And so these two cancel each other. We get 3 and minus 3 square root of 3 precisely. Y is r sine theta, and sine of 150 is the same as sine of 30, which is 1/2. And remember, sine is positive in the second quadrant. We get 3. So 6 comma 150 r comma theta is minus 3 square root of 3 comma 3 in rectangular coordinate system. Now let's go back. Let's go with a rectangular coordinate system 2 comma -2, and we want to find the polar. So you go 2 to the right, 2 down, so to locate it. And reminding you for the rectangular x comma y, polar is r theta, x squared plus y squared is r squared, and tan theta is y over x. As always, you got to pay attention to the quadrant and therefore adjust accordingly. So having said that, x squared plus y squared equals r squared. You're going to square this, you're going to square this, and add them up, and you get 8. So r is square root of 8, which is 2 square root of 2. Tan of theta is y over x, which is -1, and theta is minus pi over 4. So we are going to write r is 2 square root of 2, theta is negative pi over 4. So 2 comma -2 is the same as 2 square root of 2 minus pi over 4. If you want positive angle, you add 2 pi, which is 8 pi over 4, and you get 7 pi over 4 in case.